Today we're going to be talking about weak acids and their conjugate bases. The first acid we're going to think about is ascorbic acid, which is also known as vitamin C. The next acid we're going to talk about is phenol. Phenol may be familiar to you as the active ingredient in chloroseptic throat spray. Both phenol and ascorbic acid are weak acids. Ascorbic acid's Ka is around 10 to the minus 5. Phenol's Ka is around 10 to the minus 10, which means that ascorbic acid is a stronger acid than phenol is. The conjugate base of ascorbic acid is called ascorbate. We can predict the Kb for the conjugate base by using this formula Ka times Kb equals Kw. In using that formula, it's important to remember that you have to use the acid and its conjugate base, or a base and its conjugate acid. You can't use any random combination of acid and base and try to expect a reasonable result with that formula. So we can calculate the Kb for ascorbate by using Kw and dividing it by Ka, which gives us a value of 1.25 times 10 to the minus 10 for ascorbate's Kb. Phenol's conjugate base is called phenoxide. Using the same approach that we did with ascorbate, we can find the Kb for phenoxide, and it is 8.9 times 10 to the minus 5. What you hopefully notice is that there's an inverse relationship between acid strength and base strength. So in the acids, ascorbic acid is a stronger acid than phenol. On the flip side, with the bases, phenoxide is a stronger base than ascorbate. Hopefully this will help you remember that anytime you have a weak acid, its conjugate base is a weak base, and whenever you have a weak base, its conjugate acid is a weak acid.